One photo is all you need to make a very good talking head video that is completely AI created.
I was the chore, the job you didn't want to do. To me, you were everything.
Dress up as Mary Todd Lincoln and help me win this presidency, or you can pack your things and leave. There's the door.
My God, I love your skirt. Where did you get it? Vintage. So adorable.
This is going to massively change how video creation or content creation is going to happen. I mean, this can already turn a lot of pictures into TikTokers or VTubers, like virtual YouTubers. I'm not sure the societal implications of this. Like, there are certain people who are saying that people will stop making babies because this is so real. I'm not getting into the philosophical discussion of how this is, but I want to get into the technical details of how massively important and how like unbelievable this is. And this is not OpenAI, to be honest. This is from Alibaba Group, which is from China. They've launched a new model called EMO. EMO stands for Emote Portrait Alive, generating expressive portrait videos with audio to video diffusion model under weak conditions. This is far beyond anything that you have seen so far, and it shows in the benchmark, and it shows in the social media craze, and it shows when you see the demo. Let me show you this particular demo myself. Like, this is a picture from the Sora, which is a model that was released by OpenAI, and they've taken that picture and they've taken Mira Murati, who was like the acting CEO when the Sam Altman was like kicked out. So they've taken these two clips. One is an image, the second one is a vocal source from Mira Murati, and they've created this video.
I think this is right now an inflection point where we're sort of redefining how we interact with digital information. And it's through the form of these AI systems that we collaborate with, and maybe we have several of them, and maybe they.
It is stunningly, unbelievably good. And it's not just this. You can do music, you can do singing, you can do talking, you can do a lot of different things. And this particular system, we're going to get into technical details, but if you want to see a couple of demos, I will link this link in the YouTube description for you to check it out. It is unbelievable. It is really good. You can do it in different languages. You can use cross references. You can change the speed. There are tons of things that you can do. Like, literally you can build a TikTok or Instagram reels just based on this, and that is exactly what people are going to do. People are going to do worse than this, but this is going to happen. So how is it happening? And that is exactly why we are here. So the way this is structured is that this entire idea here, what they're trying to do is they're trying to build a model. The model should overcome the limitations of traditional techniques. And what are the limitations of traditional techniques? The current techniques that we have got often fail to capture the full spectrum of human expressions, the uniqueness of individual facial styles. And if you see the demo, you would actually see that. Like, for example, you can see like the way eyes blink, the way you can see the lips move, and like you can see the expression here. So all these things are not very common with the existing technologies or the existing solutions that do this. So to address these issues, they propose EMO, a novel framework that utilizes a direct audio to video synthesis approach, bypassing the need for intermediate 3D models. That means you don't need to build an intermediate 3D model. You don't need face points for you to do anything. So all you can do is you can literally give an image and give a clip, and then it can create the video for you. Our method ensures seamless frame transition. This is a very important piece. If you have seen the Will Smith eating noodles viral video, not the original Will Smith, the AI Will Smith, you would know that frame interpolation or the transition between frames is very important. The coherence of that is very important, and that is why Sora has been so impressive. And consistent identity preservation throughout the video. That means the person has to look the same throughout the video. You don't want like three different people, three different photos, three different faces to represent one person, resulting in highly expressive and lifelike animations. Experimental results demonstrate that EMO is able to produce not only convincing speaking videos but also singing videos in various styles, significantly outperforming existing state-of-the-art methodologies in terms of expressiveness and realism. And how does it happen? Let's quickly go into the architecture. So if you see this architecture, there are certain parts that you can understand. One, that this is a diffusion model, like underlying it is a diffusion model. They take latent noises and then they try to denoise it and then ultimately get the final output. So that one thing is clear. There are a couple of things that they're doing in addition to that makes this unique and it makes it high quality. And the one is having a reference net. What the reference net is doing here is that the input image that you give, the reference net is going to produce a motion frames based on that image. Like for example, if you give an input image, what would it look like if this particular image talks? So it creates a bunch of frames with respect to the reference the image that you give. And that reference net is referenced in the future. That's what you can see here. And it also has got its own speed controller that helps in controlling. That's what they mean by weak conditions. That helps in controlling how fast or how slow something should talk, something should move, something should do. Along with that, they also have something called a face locator, and face locator is extremely helpful, one, in preserving the identity and also in the way the frames are transitioned. So the details of it. So they have got this backbone network, what they're calling as backbone network. This entire thing is a backbone network. What is in their backbone network? So to get the multi-frame noise latent input and try to denoise them to consecutive video frames during each step. So you want basically the video frame. If 1 second is 30 frames, you need to generate all the 30 frames. The backbone network has a similar unit structure configuration with the original SD 1.5. Like Stable Diffusion 1.5 they have got one structure that will make these images similar to the previous work to ensure the continuity between the generated frames. Like I said, if you think about Will Smith eating food, you want the first one to like hold the spoon, move the spoon, take the spoon, like this is like multiple different frames and you want it to be continuous, you want it to be coherent. The backbone network is embedded with temporal modules that helps you understand the time. To maintain the ID consistency, like the face consistency of the portrait in the generated frames, we deploy a unit structure called a reference net. That is exactly what you see here. The reference net is helping you keep the ID intact of the portrait that you're creating parallel to the backbone. It input the reference image to get the reference features. To drive the character speaking motion, audio layers is utilized to encode the voice feature. So you can see the audio layers available that helps you make the character speak. And to make the motion of the talking character controllable and stable, we use the face locator and a speed layers to provide the weak condition. So you've got the face locator and also the speed value, which is a speed encoder to control how much, or also to give you that control. Like you want to be able to control how much you want to talk, how much you want to let it talk, how much you want to let it move the head and all the things. And the result is pure magic. There are a lot of interesting details here. If I have to go to the benchmarks, you can quickly see the benchmarks. One of the very interesting benchmarks here is that FVD, that I think stands for like Froche video distance. So this is a metric that understands how the AI generated video is closer, the distance between the AI generated video, how closer it is to the original video, like if it is real video. And you can see this one has got the lowest between all the other methods that you have got: Wave to Lip, Sad Talker, Dream Talk, GT, and the one that they've got. And this is quite an amazing thing because you can see all the other metrics and then you can be like, wow, this is actually true. But the thing is, it's not just the benchmark. You can see the generated frames. You've got the reference image. The quality of individual frames is good for different type of pictures. You take animation, it is good. You take real human picture, it is good. You take AI generated picture, it is good. And this is exactly real. I guess this is Leonardo DiCaprio, I'm not sure, but you can see all the differences. Not everything is 100% accurate. That's exactly like where the room of improvement comes in. But you can see the difference in the quality. They've used something like diffused head and their own system. Like you can see the reference images that it creates is super amazing, and that results in magical real-like videos that can probably replace the human YouTuber, human TikTokers. And this is also going to create a lot of spam. This could be on dating site, this could be, I don't want to mention a lot of different websites, and this could probably create albums, this could create music, this could create a lot of other things with human portrait. All you have to upload is a picture and audio. I don't know, like I said, like the philosophical implications of this is like quite scary at this point. It will start, at least for me, to question reality. I mean, this one, if you see the Joker, which is Joaquin Phoenix's Joker talking in Heath Ledger's Joker's dialogue, like it's not like you can see all the expressions like Heath Ledger, but still it keeps all the things on the face intact. It doesn't distort. It is quite amazing. And I think like all the expressions that it creates is like, for real pictures and AI generated picture, is really amazing. For me, at least, it will make me question reality. Let me know in the comment section what you feel about it. I'll link the paper in the YouTube description. The code is not yet shared, but looking forward to see the code from Alibaba Group. See you in another video. Happy prompting.